Welcome back to a very basic space program. In the last episode, we put our first satellite into orbit. It wasn't a very impressive satellite. It basically has a battery on it and it's probably run out of electricity by now, but it's up there and it completed a mission. So in this episode, we're going to do something again, a bit like that, but we have to decide because we're also going to have got quite a bit of money we need to spend. So let's get on with it. Welcome to episode 15, I think this is. Thank you for all those who have left comments and things like that. I will get back to you. I will try and include them in the series and get involved with them. But here we are. We've got some missions that we want to look at. And we had a quick look at these last episodes. So we've got first scientific mission, which is going to require that we use a Geiger-Muller counter. We've got first solar-powered satellite, requires we use solar panels and we maintain charge in it. We've got first polar orbit, which is should be easy to do with the rocket we have, gives us a little bit of funds. And then we've got things like advanced biological suborbital, which is interesting. So this gives us less than the others, but it will give us some science. So I think we need to think about that. That might be one we want to go for with just maybe the first stage of our launch rocket. I think that might be an idea to try that. We might have a go at that. Instead of using the upper stage as well, so that would cut down on the construction time. So I'm going to have a look at this. I think definitely we're going to look at polar orbits, but I think we need to spend some money first of all, because having 2 contracts maximum, but to start with, that's not a good idea. So let's spend some money. So the first thing I want to do is upgrade mission control. Let's take that to 3 impossible. So that's going to take some time. We can actually see in here, if we go into the tech, it will show us mission control is going to take 137 days to do. So that's not terrible. Now, we could go for a bigger launch pad. However, I think our 60 tons now is fine for the launches we're going to do. It's all about tech now. I would love to uprate this, but I can't because we don't have the lunar range stuff. We could save up to do this, but that would then mean we could go over the 20 science mark with our things, which is going to be this band here, I think. Yeah, so I think we're looking at if we're going to basic capsules, we're going to have to do it before basic capsules, I think. Is that right? These would do it. I think I can get 20, so these 2 I can't. So we're almost at our limit for these. So at some point we're going to have to think about saving up the cash for that, but we might do that with some of the stuff as we go along. So in reality, I think what we're going to do is we're going to pile a load of this into our funds into this. We'll leave a little bit there. But I'm going to stick, let's see, we want to retain a 2-to-1 ratio, I think. That's what we're going to go for, 2-to-1. One of these, 2 of these. So get the VAB up 1 point, and then we'll go R&D 2, 3. So now we can go VAB for 1, and then we'll stick the next one in the R&D, what has it done to our vessel building time? So we're still going to spend 160 days building our vessels. And our tech is down in time. That's good. We've got quite a bit of a chunk out of this, so we're down quite nicely. We've spent a bit of funds there. So I think we're going to go for a polar craft. We're going to have to, let's see, when we get in science, let's have a look at what tech we've got. We might have to rearrange it a little bit. So let's have a look. We could get this. This looks interesting. 2 hours in satellite. It does biome. Right, so that's not biome specific, so that can go on any craft. The advanced biological capsule we need to recover, so I'm not worried about that. And then we've got all these. I really want to get to these, so I think we need to go for a satellite era science. We need to get that because that's going to give us just science up the wangzoo to deal with, and we can use that to get upgrades. We can use it to do other stuff. So let's have a look. How do I get satellite era science? I think we're pretty much there, aren't we? We just need to do that. So that's going to be 200 days. So we're going to have a couple of flights before that. So let us have a think. This electronics will give us, I believe, the solar panels. Is that right? Yeah, we're going to get some basic solar panels with this. So we'll do the solar flight then. And then we can do them. So instead of doing all of our rocket launches, we could actually technically do all of those missions in one launch if we'd got the science organized right. But we can't actually do the solar powered and the scientific because we don't have the equipment for it. So we're going to do the polar, I think. While I think about this, I'd really like heat shields for this, but I think I can do that first stage without. So I'm going to do this polar one. We'll use the craft that we've got. It's already done. I've repainted it, so you can have a look at that. And I think we're going to have a look at this one as well. How long have I got left on these? Oh, tell you what, we'll stick up an X-planes high as well. So that's going to go up to 65. Right, do that. Uh-oh, just remembered we don't have the Coniston anymore. Guess we better rebuild it then. Right, I'm going to go and rebuild the Coniston out of whatever's left of it. We'll take off the biological sample and things like that, and then I will get back to you. Well, here we are having a look at potentially the new Coniston. I've basically opened up the Coniston 3 Recon 2 that had the wings ripped off it, and then I just loaded up the Coniston 3, the basic Coniston 3 without the extra components, to see what time it would cost us to actually put the wings back on. It's the easiest way to do it. This is only going to take 10 hours, so we've actually, one of the little, I think, probably things with Kerbal construction time is because we've got extra time involved in the scientific units. By taking those off, it sort of sets against the time putting the wings back on. So I'm quite happy with this. It's a little cheaty, but I'm gonna accept it. We're going to save these edits, and we're just going to use the Coniston like this now, with the realization that we're paying a penance because we got quick wing reattachment. So the Coniston is back. We should probably not rename it the 3, but we're going to. We're going to keep it as it is. We're going to save those edits, and we're going to launch it, I think. We are flying with Janet Riley, and we're just going to climb up there as fast as we can. Get the fly-by-wire engaged. We're going up. Interesting. It seems the fly-by-wire is allowing me to really fire this craft around a lot more than normal. That's interesting. I wonder if I've hit some changes on it, because normally it sort of limits it. I wonder if I've knocked something off when it took it out. Let's try knocking it off and then engaging again. Right, there we go. Interesting. It seems to be much more responsive all of a sudden. We've just had a really heavy tail end on the craft that I didn't realise. Right, we're just going to fire this up. Whoa, fire this up at 45 degrees. We're going to aim for 65, I believe, is the target. Let's have a look. I should point out, actually, in the episode where we went to orbit, I did not tell you the name of that orbiter. It's called Orbiter 1. It's not an original name. We've not come up with an original name for it. Orbiter 1 is the name of it. Right, we're up to 40 now. Right, I'm going to slow this down because I want to manually control this. We want to just touch the target altitude. I don't want to go past it. Right, 65. Right, there we go. I'm going to pull our engines right back. Turn them off, actually. We don't want to overstate it. We can actually restart these engines as well, which is nice. So we'll just do that. They're pressure fed. I don't know if they require ullage though. Do they require ullage? It doesn't say anything about ullage requirements. So if we're short, we might do that. All right. So I've shut them off because I don't want to hit over 70. Once we get over 70, once we get over 75, 75 is the killer for this cockpit. So I am going to just let it fly up to 67. So I think we can definitely get 70. We've got the fuel to get 70 if we go sharply up. However, are we actually doing anything? Oh, we're too high for the science. So we're coming in. Oh, I've still got this set to flying from the north. So that's what's throwing me off. I need to reset the direction. So we're actually going to come pretty much over the Cape there. I think, is that the Cape there? Yeah, probably is. So we're going to come straight over the Cape. How nice that is. Because obviously we're used to doing a bit of science while we're doing these things, but we're not doing that anymore. Right. We're just going to tilt forward. Now, obviously, we're higher up in the atmosphere, so our response with our tail planes and so forth is much different. And there we go. Oh, I've actually set it off on a little turn. Now we're going to pull it back. All right, there we go. That's fine. Just pull up just a little bit. There we go. Once it starts moving at this sort of altitude where the air's got really thin, it will just keep going. So let's just fire this down there. We'll land somewhere down the tip of Florida, is it? I'm terrible at American geography. I apologize. If it's not Brazil and its major products in the 1990s, it's not geography for me in the American continents. That's a little geography joke there. If anybody ever did geography in the 1990s in the UK, that was one of the big things that I remember from it. You had to know a lot about Brazil for some reason. All right. So we're coming down. We're going through. We're getting into the thicker stuff now. So we're actually going to deploy our brakes, which are rubbish. We need to really, you know what, I should have actually stopped building this craft and actually just put better brakes on it. We will need them in the future, so should really develop them. In fact, you know what, next time we pull this in, we'll actually look at putting some sort of air brake system in place. I'm not sure this structure here needs to be the shape that it is, so I think we can keep the bottom as it is and do something interesting with this plane. I don't know. Right, we're coming down. I suppose we can actually just let it do its job. It's going to slow itself down as it comes in. Oh, what's that there? A little bit of buildings there. A little bit, that'll be the launch site over there, I'm guessing. And then we're coming in nicely, and we're just going to put it down here. Somebody knows geography. What's south of Cape Kennedy? What's down here? What am I about to land in? Is it swamp, or is it a town, city? Am I going to cause a problem? I don't actually know what's going to go on there. And we're just dropping it down, so we're now coming close to dropping out of the speed of sound. Got a bit of movement there. Look at that, a bit of wobble in the air. That's interesting. Now I thought I turned that off. I wonder, we had a crash, a KSP crash, before the wing ripped off episode, and I wonder if something's been changed during or after that crash with the actual persistence file. It's almost as though something's not updated properly. So there we go. It's quite interesting. Right. Now let's pull this up just a smidgen. I just want to hold it level-ish. There we go. With that speed, let that speed drift off a bit before we deploy other parachutes. Want to get below 200 because we know 200 is killer, which is terrible. In fact, you know what? We're going to get down as slow as possible. We'll do a rise and fall. So there we go. Whoosh. You know what? Stop doing it when the power's on. There we go. There we go. Right. As soon as we start falling, our parachutes will deploy. There we go. Thank you. And we just got to drift down to the ground now. Wonderful. Let that speed up. Pull that in. Right. Going down. Ooh, that's vicious. You get whiplash there, Janet. Yeah. Yeah, Janet is flying again. I can't remember who was in the last flight. Oh, it was Carl, was it? I think it was Carl. I don't know if he'll be going in another flight. It's not a good idea. So we're going to pop this down, and then we will go and do our polar launch, and we can see how much more difficult that is. We should have the Delta V for it. I'm hoping we've got the Delta V for it. We don't actually need to get to completely polar. We can actually just we can get sort of semi-polar. It doesn't have to be exactly 90. I think you can have an 85 to 95 range, so that's good. But we will have a look at that. Right, as this pops itself down, we'll get all of our rewards from it, and we'll get on with the next craft, I think. Right, we got a tiny little bit of science out of that, and we've got all the things back. So we are now recovering that vessel. We've got 150 days to go until that craft is ready. We're going to get satellite era electronics before then, and we're actually going to get early science as well. And we're going to be close to getting that satellite era science. So I think what I'm going to do is we'll spin forward to the point where we get early science, and I'll build something. Right, so we've gone forward a little bit of time now. We're still waiting for our craft for polar launch to finish, but we have finished satellite era electronics, which now gives us solar panels. Just the first starting ones, they're not very good. And it also gives us this early science, so we can now have the advanced biological capsule, so we can actually do that mission. And we've got the ion mass spectrometer, which has to fly in space and sends data back. So I'm going to put together a craft, I think, that's going to be solar panels and the mass spec, and we can use that for our solar contract. So let's go and put something together. Right, we're going to put together a solar satellite, and it's not going to be pretty, it's not going to be clever, it's just going to be basic, but we want to get this mass spectrometer on it. So I have opened up a science core. We've gone to avionics prototypes because we've just finished those earlier. I had to pay a bit of funds for that, so that's gone out of here. We put a little bit of electric charge on it, so it gives it 13 hours. We shouldn't need that, you know, it's going around pretty quickly. So close that, and I've made it this size. We've actually got a lot of excess space on it. It's actually going to weigh more than it needs to, but we'll put it on a rocket and see if we get enough Delta V. We should be able to do this easily enough. So 500 by 500, so 50 centimeters by 50 centimeters. Then we have got ourselves some of these solar panels. These are the first version you can get, the lowest sort of level, lowest quality. They're not particularly good. Take level 0, not going to produce much, but all we need is a positive just in general of this. So that's what we're looking at. So we want 4 of those around the center of this, and then I want to put another one on the top, just one. So we're going to put one on the top, and then another one underneath, because we want to basically, this craft is going to be floating around in space. It's not going to have any control. So these are 900 by 900. That should give us perpetual electricity. It gives us quite a lot actually, but it means we can do science while we're up there. What we could do is actually increase the range of this antennae possibly. Will 40 give us a nice thing? That starts to eat into our supply. So let's look at the antennae first. So we come over here I don't want that. Get rid of that for now. We don't want the science. Oh, by the way, I put the science in there as well, but I can show you. You do that down the bottom here, configure experiments. So, real antennas has changed, and this is something I have just noticed, which is that you used to be able to put in your sort of details here, and you could do all sorts of planning just really quickly. I don't know if you can still do that. I cannot see it, but the antenna planning section has been updated. Now, note to self, I know that if I click on here, it will click through and do something to this craft, so I have to be careful. So, my primary vessel is going to be Solar 1 Avionics, okay? And my peer, I'm guessing where I'm communicating to, is just going to be just one of these UHFs. Let's look at Woomera because it's a standard UHF. Right. We want to go into an orbit that is going to be what? Let's put an extra 0 on that and just see what happens. If we hit the plan button, we do not get any signal at that height. Okay, so let's try again, a bit lower. If we go to 1,000 kilometers up, we're getting signal. So 1,000 kilometers up, we get signal. We know we're going to orbit around 200. Our minimum paraps is going to be 300. So let's be careful. Let's give ourselves, you know, a big chunk of stuff. We can go up to 2,000. Can we go up to 3,000? We can go. Oh no, we can't receive at that point. So let's go to 2 again. So 2,000 kilometers is our limit. We're going to be 2,000 kilometers above these. Now the interesting is that is directly above. So that's going to be close. We're going to have to be hovering over things. So we may want to go into polar orbit with these things because we know at some point we're going to pass over an antennae, hopefully. So that's something to think about. So that's where we're going to sit with this, and hopefully it's going to be able to communicate when it passes by something. But we want to put it in a reasonably low orbit. Now, let's fix this craft up a little bit because it's a bit janky, isn't it? Look at that, it's a bit sticking out and all sorts of stuff. So we're going to use the offset tool here just to tidy it up. So we're going to use the offset tool, and we're going to first of all put these side panels. You see we've got it onto the toggle snap absolute, and then we just do that and it brings them in. But they're all now going to be on the center of, they're going to be lined up absolutely to the center of that probe. I don't need mind about how far out they are at the moment. That's not important to me. Next thing, take the top one. Just tap it and it will do the same for that and for the bottom one. And you're now thinking that looks like the worst satellite ever. Yes, it is. Don't worry, we're going to fix that. We're going to go back to the top and grab it. And we're going to hold down our shift and just pull this up until we don't see any of the panels from the sides. And then we're going to do the same on the bottom. Okay, you can see where I'm going with this. There we go, just ever so little. There we go. Then we're going to grab the side ones and just pull them out, all like that. There we are. Isn't that wonderful? That should be perfect. There we go, perfect cube. Solar 1 is ready. It has a mass of less than 100 kilograms, and it should be capable of doing everything we want to do. Importantly, and this is very important, it should also enable us, can we get in there, potentially to add another science experiment to it. So we might be able to put onto it the Geiger Müller if we need to do that. So we're going to save that, but we're going to have to put a craft on that at some point. So let's think, how are we going to do that? I know. Right, we're going to make some modifications to our launch vehicle. We're going to put this underneath the satellite that we've just built. So first of all, we're going to rename it to the 103. It's going to become the Javelin 3B because we're going to make some changes to it, and we're going to obviously change this because we couldn't possibly put the wrong number on a craft. That would be terrible for us. So that's changed as well. Wonderful. Oh, that's done that. So what we're going to do is we're going to save this, and then we're going to reload it, and the number should reappear. There we go, as if by magic the number has reappeared. So what do we want to do? We've got a couple of things we want to do. First of all, we want to sort out our avionics because we have better avionics now, and I want to uprate that. So we're going to put that in there, and I only want 400 units there. I want 0 extra space. Apply that. Wonderful. Right, next down here we have avionics as well, don't we? Where are we? There we are. This we're going to uprate as well. Again, we're going to have 200 units of that with 0 extra space. I'm going to apply that. That's going to hopefully save us some stuff as well. There we go. Close. Ooh, it's change that to 60. Thank you. And apply it. Good. Right. So we've gained quite a bit of delta V just by doing that because we've gained we've lost mass in our avionics systems. So Next, we've got our payload up here. We have our first stage here. We're actually going to pull the first stage off for a second and look in here. We're going to pull this fairing off. Now, we currently have 6,000 meters per second in this stage. That's more than enough. But what I want to do is actually improve it a little bit. So we're going to give it the ability to do some stuff on orbit. At the moment, once this engine burns out, we're basically stuck in whatever orbit. I want to give us a little bit of variation so we can actually change our orbits a little bit. Now, I could put some extra engines on and things like that. I do not have. Ideally, I'd put 1 kilonewton thrusters on and use those and stuff, but I don't have them. So we're going to use some attitude jets, and we're going to use a few big ones maybe. Got a big one? What's the biggest that I have? That's tiny. We don't want that one. Let's go with these. We'll go with 4 of these, I think. So we'll go 4 of these. Now, if I put them down here, they're going to be blocked by the engine. I could sort of put them on this plate, I suppose, and imagine they're piped in. I could also put them on the outside of our fairing there, facing down off the edge. However, that sometimes with this game leads to occlusion, and I don't want to do that. So what we're going to do is, it's less efficient what I'm about to do, but we're going to just sort of basically tilt them. So I take these, I've set them to be in this long shape. I'm using the internal style ones just because I like them. I really like what they give you. And then we can just tilt them like so. Now that's fully, that will give me 100% of my thrust down, okay? However, I'm going to be occluded there potentially. So I'm going to just tilt them out a bit. And then I'm going to reposition them just a little bit like so. And I want them, basically, I'm going to lift them up a little bit though. I want them to be about here. And then pull them in, and then I want them popping on the surface just a little bit. There we go. So that's going to fire down. It's going to give me a little bit of thrust to the side, but that's going to cancel out across all of them. So that's going to I'm happy with that. And we're going to set them to HTP. We're going to put HTP in it. Okay, right. HTP is required. So we need to put some HTP in, but we also want to give ourselves some control over direction here. So these are going to be firing downwards. I could get them to do some sort of control left, right, and fore, aft, that sort of thing, but I'm going to stick a few other of these on. Now, I could do roll control, but I'm not going to. I don't mind if this thing starts to spin, actually. We're going to give it sort of 4 axes of control, so that's not a big issue. But, yeah, that's... I don't really mind if it starts to spin massively. We may come back and add some sort of roll control onto this, but I'm not going to at the moment. So these ones are just going to be as they are. We're going to change them to HTP as well. There we go. And we're just going to recess these into the body of the craft so that they are not sticking out like this, because they're designed to just sit down. And I'd imagine these would just, I can imagine these being sat, this is a pressurized vessel, I can imagine them being sat in the section where the curve is here, because you've got a big section of curve there. We'll just imagine that. So that's where they're going to be sat. There we go. That's done, sorted. Now we need some fuel for them. So I'm going to use an integral tank. We're going to put, let's see, I just want 2 of them. Give me 2 of them, and I want there like that. So that doesn't look very good, does it? Well, we're going to change this to we've got a filleted cylinder. Max out the fillet, and then I'm going to pull this down to, I think, about 4. We'll try with 4 or 3? 4. Let's go 4 now. Yeah, let's go 4. Max out that fillet, and I'm actually going to put them on the side. I like them to the side, to my sides for some reason, like so. And then we're going to make that, let's see, will it let me do it? It will not, because I've got to have it pressurized. There we go. So will it let me do it now? There we go. So we can have HTP and helium in it. What does that give me? That gives me 29 units of HTP, which may be enough once the fuel's burned off on this. It may be enough for us to actually do some useful stuff with this. I don't know. We'll have to practice on orbit, which will be quite interesting. I have not used sort of standard systems like this for so long, because I'm doing the British Space Program one, where we're using a lot of HTP, kerosene and things like that. I'm actually not used to the standard fuel mixtures, which is quite amusing. So I'm just going to move that into that sort of webbing space there where it'd be grabbed onto. And of course, if you really want to, you could just change this over to foil, which would be quite nice. It might have been better actually if we put it in the air. It's fine. So there we go. That is that done. We've dropped our our amount of thrust though down by about 400 meters per second, which is significant by doing that. So we need to be aware of that. We also want to take these RCS thrusters and move them above our engine and be above the fairing as well, because they're going to be the last thing that we fire. Not the most efficient way of doing things, but it's what we're doing. Right, and then we're going to take this, plonk it down here. There we go, and you will see that's actually increased our delta, well, decreased our delta V significantly by doing that. So what we're going to do is we're actually going to see what happens if we drop this this down. You see, look at that. That's a massive change that we get there, a huge change. But the majority of it will actually be the tank. So let's try taking the tank down a bit more. And that gives us another big chunk of stuff, but we've got very little in the way of fuel now on board, and that's a problem for us. So yeah, we have to be aware of that. We've gained a lot of power back with a lot of the stuff that we changed there, but potentially this craft will have difficulty getting to orbit. So we need to be aware of that, particularly if we put a bigger payload on the top there. So we'll need to think about that. So we may not use this craft for the actual the mission it was originally intended for. We may just test out something else first. I want to try with our polar orbit to see if we can actually get to a nice high periaps, because if we can do that, then that's not going to be a massive problem for us. Right. So here we are on the launch pad with J102 on top of it in this fairing here, this extended fairing, because we've actually got an extended fairing. I should have pointed that out. We've actually put an extended fairing in the J102 because we're going to use this size fairing in future, because it gives us more options for what we can put as payload. Inside there we have Orbiter 2, which is a copy of Orbiter 1. This craft was originally the backup for our first orbital launch, and hopefully it will survive this launch. It's likely we get a failure at some point. I would prefer it to be this craft than the next one, so there's a bit of me hoping in some ways that this fails, but if this goes off without a hitch, I do not have a problem. So everything is ready. We're going to be heading slightly to one side of north. We actually, if we headed straight on a heading of 0 degrees, we'd actually have our inclination go up, but we might not make it up to the 85 degrees inclination that we actually need. So we're actually going to go back on ourselves a little bit. Currently, we're going to head off slightly to one side of 0 and just try and cancel out some of the sort of velocity from the Earth's spin. And that is, if we actually look down here, we've got an orbital velocity of 400 meters per second when we just sat on the surface. So you can see there's quite a bit of velocity to get rid of there. Anyway, enough talking. Let's get this thing up there. Let's yeah, we'll do that. So engines are ready. We're going to fire them up. Both are starting, and then away. Right, we are off. We've got that usual slow start. Obviously, as this craft develops, we're going to hopefully get a more thrusty engine. We alternatively, when we get the research, are going to be able to stick some solid boosters on the side, probably caster ones on the side. Any of those things will increase our sort of payload to orbit. At the moment, I think this craft, however, is capable of putting something into orbit that may be able to go to the moon. So we're looking good for the next sort of step. Now, I don't expect that payload to actually land on the moon or orbit the moon, but I think we could get an impact at least, or a flyby. So that's a nice positive. Right, we're approaching our 100 meters per second. That's when we're going to start tilting over. There we go. We're going to start tilting now. There we go. Now, all we need from this mission is a periaps above the atmosphere. We just need orbit. That's all we're looking for. So we're just going to head up for that. We're not aiming to do the solar contract. We're not aiming to do anything else in the scientific contract. We just want this polar contract. If we fail this, we fail it. It's, you know, we can get it with the next flight potentially, but this takes us a little step forward. We could actually have scrapped this rocket and actually just gone for the next one like 30-40 days early. But I think it's probably, we might as well do it. We started building the J102, so we might as well finish it, and we're just going to keep heading over there. I'm actually losing track of this. Now, I could put MechJeb's PVG on this to try and help us go into a more effective orbit. I actually don't really use it, if I'm honest, so I need to figure out how that would work and how it would play with all the parts of our rocket and see how it would fit. You can see already we've still got 9,000 meters per second of delta V though, so we should be okay. Our inclination is now up to over 40, which is nice, and we're going to tend down a bit more. We're going to drop it down to 55 degrees, 53 degrees, 50. Put it to 50 degrees. There we go. It's a bit of an extreme one. And the gimbal on this engine, with the addition of our, and you can just see it there, our little LR-101, giving us that ability to gimbal, is really nice. It's actually keeping us on track with our flight quite nicely. We can go down to 45 and beyond. I think we're going to head down to 30, and we need to really work on this this launch profile to try and simplify it a little bit, because I'm still sort of eyeballing it a little bit. We're going to have to burn longer with that upper stage. So previously we actually were getting to orbit with quite a lot of fuel left. We're going to not have all that fuel in this upper stage this time. We're going to actually need a lot more of it to get to orbit. So let's have a look. We've got about 30 seconds left. We've got a lot of delta V on that stage still. We're going to let it keep going at this sort of level, 30 degrees. Keeping an eye on this time to apoapse, that's important. Keeping an eye on our inclination, we need that to be over 85. Once it gets over 85, we'll zero out our heading, and it'll just keep climbing until it heads towards where we want. Right, and I think we are about to get ready for main engine cutoff and second engine ignition. Let's have a look. We're going. Oh, we have gone very high actually. Fire that engine, there we go. And we want to be, there we go, sorted. Why are we not turning? I think our gimbal on this is not particularly strong. Right, we're going to decouple those fairings. There we go. And there we see the tiny little Orbiter 2 just nestled in there on this craft. It's a tiny payload for this craft. It can take much more up into orbit, I believe, and we're going to definitely push that in the future, but for the moment we don't need to send much up. We're just sending this little test payloads up, getting used to this craft. We have a long burn ahead of us on here. We actually have gone very high, so what I'm going to do is we're going to set this to 0 now. We don't need it. We're actually going to put our pitch down, which is sort of counterintuitive. We're losing some of the excess we've done. We actually went very high there with that initial boost stage, and this is what I mean about learning this rocket a little bit. We're actually still going very high, so we've got a very high angle coming on there. You can notice we've got a little bit of roll, which is quite interesting. So if we engage a bit of roll control, does this craft have the ability? Yes, so this engine can control its roll a bit right now. We're starting to bring that down. Interestingly, this suggests to me that we could actually do the contracts that require that over 300 kilometer launch. That's quite interesting. We might want to look at that as a possibility. Just go for a steeper initial launch with that first stage, and then that would save us a lot of messing around with RCS and so forth. That's a nice idea actually. Unfortunately, yeah, our time to apoapse is not really going down as quickly as our fuel, which is going down. Now our fuel is all over the place actually. It's sort of quite stuttery, which is quite interesting. I wonder what's going on. It feels as though we're about to have an engine problem almost. I just wonder what's our mean time between failure. We've got a lot of time on this. This engine is doing really well actually, if I say so myself. They start out the RD-0105 starts off with a lot of reliability, and I don't know if obviously it's historic, but I didn't realize that it was actually that good as with regarding its reliability. So, you know, kudos to the Russians on the development of that engine. So, yeah, right, we're just going to take that to 0 and just slowly bring it off. It's very slow to change that. I wonder what its actual gimbal is. I'll have to have a look at some point. Restart ignition, shut down, lots of interesting stats. So obviously there's been changes made to Realism Overhaul, particularly an RP-1, particularly things like the sort of changes to test flight, which is, you know, total runtime and current runtime and all that sort of stuff, so you can actually have the two numbers run separately. Ignition chances obviously, but also restart ignition penalty because of the number of restarts, the time between restarts, all that sort of stuff. You have to start taking that into account. That's really quite nice actually. I quite like that. We are actually going to have to put our nose down again a little bit because we've gone a little bit too far on that one. So there we go. just pull that down because we're trying to keep this lower than this. That's the concern we have. We want to just keep that down. We are definitely going to be within the range for that polar orbit. All we've got to do is get orbit. That's the big thing we have to do now, is just get to orbit. So that's what we're hoping. Right, this is going to require a little bit more pushy downy. There we go. We need to keep that lower than this, otherwise we're going to overshoot and got all sorts of problems going on. Right, and we can now zero that, I think. Oh, actually, no, hold it down a little bit. Keep it down there, just a little smidgen more, and then we'll just zip it to 0 when we get near it. And I think now, there we go. Pull it, there we go. Right, this should be reasonable. So we're going to be burning quite nicely. And get ready to shut the engine off. I don't need this thing to be in a high orbit of any sort. In fact, it'd be better if it was lower. So there we go, and there we go. Cut the engines. So we're at 1,000 meters per second left. That's wonderful. So we know that we can go polar, and we can put 1,000 meters per second on this craft. We can reduce its delta V. So let's check. What we've got: telemetry, pressure, temperature, all done. Wonderful. What we can do is just decouple, and then what we can actually make sure we do is rename this, because this is Orbiter 2. There we go, Orbiter 2. Accept that, and that's just going to float around until its battery dies. It's the least interesting probe we've ever got. That's basically, it's just a box, not even a sphere, not even Sputnik, not even Explorer with its long sort of rod. Not even Vanguard, which was like basically like a tiny Sputnik with lots of spikes on it. No, it's a cube. That's really uninteresting for us. We should probably have made something more interesting, but it fulfills our role, and it was cheap to build. Obviously, the original Sputnik was going to be Object D, which was going to be a huge structure, and they actually cut it down in the end. So let's have a look. We're about to finish this. We just time warp this, I think, and we'll just do that. The rocket back there is running out of electricity. That's nice to know. So we know that that's going to run out pretty quickly once it's launched. There we go. Now, what's our battery life like in this? Actually, it's worth just having a look. Where are we? It's this, isn't it? So we want to have a look at Orbiter 2, and I want to look at comment. No, although no data. Where's the button? It's not telling me. Electric charge. Oh, 9 hours. So it's got 9 hours. That's not bad, actually. That's not bad at all. Right. We're going to go back, yeah, and the carrier there has run out of power. So these pieces of debris is going to float around in orbit. Right. Let's get back to the space center. Right, we are back at the space center. We've got some rubbish on the launch pad we need to tidy up. I'll do that in a minute. We have completed that mission. There we go. 48,000 goes into the account. Isn't that nice? We have this vessel being built. We're actually I'm going to make a duplicate of that while I think about it, and we'll just sit on it a little bit. Right, and I think I want to. Let's have a look at the tech situation. We're running through that quite nice. So we're getting it through solids easy enough. I think we might actually ramp the solids up a little bit. Just get them done just a smidgen earlier, because that probes is earlier Veroxin probes is important, but I'd like to get my solid rockets underway, and we're going to need lunar range communications as quickly as possible, actually. So do we move that up? No, we'll keep that where it is. I do want to upgrade this at some point, primarily because it would give me let's get this out of the way. It would actually give me patch conics being visible instead of just orbits on the map, and patch conics would be really useful for us when we actually want to do anything important. Right, so we're going to call it for today on this one. Next time we're going to try and do our final set of orbital contracts, the scientific one and the solar one, and we're probably going to push the Coniston to near its limit as well, so that's going to come close to blackout time for it. We're going to see how that does, because that may be towards the end of its time as a rocket plane for us. So please like, subscribe, and until next time, have a great one.